the problem is store the colors and in place. So there's an array numbers with n objects, color red, white, blue, and we're gonna use 0, 1, 2 to replace these three colors and store these numbers in place. So the first idea came to my mind is I'm going to use count method to first count the occurrence of 2 in array and 0 and lastly 1, and then iterate through the input and replace all the numbers with the occurrence of each number in dictionary respectively. So here's the steps: div sort color. First, use dictionary for number in numbers. The number will equal to d dot get number. If it is never encountered before, set the default number as 0. If not, increment by 1. Then we will get a dictionary of occurrence of each number in D. Then iterate through I range 3 and for dash in I. So you will first go to the dictionary, find the value 0. If in this example, there are 2 ones, so it will iterate 2 times, and numbers use indexed equal to I. I'm going to use another iterator, initialize it as 0, and set an indexed increment by 1 every time it replaces the origin number with the new number, and return numbers. Let me put in numbers. Yeah, it does do the job. It stored the inputs. But in this approach, first we count the occurrence of each number, which is time complexity of big O n, and then we create the numbers of each value in various occurrence, and we do it 3 times. So it's gonna be big O n squared. So this is so the overall time complexity is big O n squared, which is not quite efficient. So as I watched the hint, there's another approach called Dutch national flag algorithm, which is a one-pass algorithm. So it goes through from left to right just one time instead of a couple times that used in the previous approach. So diff sort color to numbers. The approach is about using 3 pointers to solve this problem, which are low, mid, and high. The low start from 0, and mid start from 0, and high start from the end of numbers, -1. So these are 3 to divide the numbers into 3 parts. So we need kind of 2 portions, 2 bars to divide them into 3. The bar here, what I mean by bar is, in this problem, is low and high. Every number before low is 0, and each number higher than high, greater than high, is 2, and the numbers in between is 1. The mid pointer plays a crucial role in this problem. So it mainly acts as an iterator. Every time we should compare the numbers the mid pointing to, and make comparison between that number and the mid, and see where the numbers should locate in numbers in the array. So while mid less than equal to 5, which means all the numbers are set in their according positions in array. So if high is less than to mid is less than mid, which means all the highs, all the 2's are after high, and which means the array is sorted. If the if the numbers mid is equal to 0, else if numbers mid equals to 1, and else. These are three conditions that the pointer mid will encounter in this array. And in these three conditions, iterate mids will perform different so each time mid pointer will perform different actions based on the numbers it encounter in an array. So if the mid is pointing to a 0 number, then I'm gonna replace or swap the index of mid with the index low. Mid numbers low. Mid. Why would I do that? Because if the number is say the mid is pointing to 0, is pointing to 0. What it should perform is that it should swap 0 or put 0 in the front of array. So it will swap the numbers in numbers of mid and low, so that the mid, the 1 is always placed after 0, and then if 0 is placed in the correct position, which is in the front, then we could move low, increase low by 1, because all the numbers before low is sorted, and then mid's increment by 1, because mid is the iterator. It should increment by 1 when iterate through the list, and then if the mid is equal to 1, which means that the 1 is at the correct position in the array, so we then move on to the next number. If the mid pointer encounter a 2, which means the numbers mid should swap with numbers high. After we do that, odd number after high is sorted is or you can say it is 2. Then we could neglect the numbers after 2, so we decrement high by 1. Let's return the value. Yet. So this is a two approaches. The first one has higher time complexity, but the Dutch national flag approach is a one pass approach algorithms, which is better, way efficient than the first one.